Okay, time to go over solutions to practice exam number 6 here. Now you have an answer key, but sometimes an answer key just isn't enough. You want to get solutions explained to you as you say, well, I see your steps, but I don't know why you chose to do that step. So please access the answer key. Go to, excuse me, now I have the hiccups. Go ahead to this link here as a hot link, bit.ly/Robinson PE6 bit.ly/Robinson-PE6. Go straight to that. Find the answer key on there if you don't have it in front of you, and please follow along as we go. Okay, the first one, we have to match each part of the circle with the correct vocabulary term. All of them will be used, and they'll be used only once. XY is this guy right here. That is a tangent line. It crosses only at one point. Tangent line. Gone. Angle RZQ. RZQ. It's right here. Here, Z is at the center of your circle, so this is a central angle. Remember the notation, that's an angle measure, not an arc or anything else. Central angle. Segment PR goes from here to here. Goes right across, two endpoints inside the circle. It's a straight line, that is a chord. Segment PQ is also a chord, but it's a chord that goes through the diameter. It's the longest chord in the circle. This is a diameter. By the way, I have sniffles. I apologize for that. Okay, arc, LM. That's from here to here. And it goes across like that. It is less than 180 degrees. That is called a minor arc. Segment, ZP. It's right here. I gotcha. From Z to P, from center to end point on the circle, that is a radius. By the way, ZQ and ZR are also radii. Just this is the one they asked you for. Last two, QPR, angle QPR. Endpoints are Q and R. Vertex is P. That is called an inscribed angle. And by the way, notice how the central angle, QZR, or RZQ as they put, has the same endpoints as QPR. So this angle is exactly half the measure of this angle, because they both share the same endpoints. And finally, arc MRP. That goes from M. They want you to touch R before they hit P, so you're going to go this way. From M over to R, and finally finishing at P. This is greater than 180 degrees, because this is your diameter. This is called a major arc. And also, by process of elimination, you would have known that this had to be all that's left. Okay, so there's some vocabulary. Moving on, number 2. Given the information in the diagram of circle P at right, find the measure of arc BC, the measure of angle BAC, and the measure of arc AB. Okay, I'm going to go ahead and start with measure of arc BC first. This guy right here, trying to find out what it is. Remember, here's a central. They say it's circle P. What that means is P is at the center. If they say circle P, P's at the center. So P's at the center. Here are two radii that form a central angle of 35 degrees. The central angle and intercepted arc have the same measure, so arc BC is also 35 degrees. Simple enough. Measure of angle BAC. Here's where I saw some people having some screw-ups here. I need to make sure that you recognize that this is an angle and not an arc. So it's not BAC like that. We're looking at BAC, the measure of this angle. First, I'd ask you, what kind of angle is it? You'd say it's an inscribed angle. And an inscribed angle is half the measure of its intercepted arc. We know 35 is its intercepted arc. We know the central angle shares the same endpoints of 35. So this will be half of that. So measure of angle BAC equals half the measure of its intercepted arc, 35 degrees. Half of 35 gives you a decimal value, 17.5 degrees. 13.5 degrees. Please leave units of measurement there. Finally, measure of arc AB, this guy in red. It is a minor arc. Here's something important to note. Well, two things. And I feel like a sneeze is coming on. First thing is that I'm trying to find the measure of an arc when I could say all of these arcs together would add up to 360 degrees. So I know that the measure of arc AB plus the measure of arc BC plus the measure of arc AC equals 360 degrees. The entire circle is 360, so all these added together would be. We know that BC is 35. I don't know what AB and AC are, but these marks here, the congruent marks, say that they're the same measure. So although I don't know, let's go and call this x. I don't know what it is, but I know that this is also x. So in this equation, I have x plus 35 plus x equals 360. So if I just solve for x now, I solve for arc AB. So 2x equals 325, I'm doing a subtraction there, divided by 2, I get x equals 162.5 degrees. So this final answer here is 162.5 degrees. Okay, problem number 3. In the circle at right, the diameter KL intersects MP at point Q. Okay, so they say that this is a diameter. They don't tell you that Q is the center of the circle, so make no assumption that it is. In fact, if it were drawn to scale, you would know that right here you have probably the center around there. So again, we know that it's not the center. We can't assume that it is. In fact, here's a good way of knowing that it's not the center. It says if QP is 6, go ahead and write this down as you see it. QM is 7, and QL is 5. Okay, before I continue with the question, you know if Q was the center, these would all be congruent, because these would all be radii. You know they're not congruent, so you know they're not radii. So you know Q's not the center anyway. So if that's all true, it asks then what is the radius and circumference of the circle? Okay? So what is the radius and circumference of the... Hang on a second, I got a phone call. I'm putting it away. You might hear a vibration in the background if it rings again. Okay. This is what we're going to do here. To find the radius, we need to find the distance from center to any of these points. Here, 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 or here. Okay? That's not from Q to there. That's from center to there. It would help us to find the radius by finding the diameter. It would help us to find the diameter by knowing that this is the diameter. So my diameter right now is 5 plus x. If I knew what x was, then I could find the diameter. Divide by 2, I'd find the radius. So the question is, how do you solve for x? Go ahead and refer to your circle stuff sheet and know this relationship. A times B equals C times D, where A and B are segments of one chord, and C and D are segments of the other chord. So 5 times x equals 7 times 6. I'll put 7 times 6. So 5x equals 42. Divide, you get x equals 8.4. So this segment here, instead of being x, is 8.4. Right there. So your entire diameter is 8.4 plus 5, which is 13.4. Okay? So your radius is 13.4 divided by 2, which is 6.7. So the radius of the circle, the distance from the center to any endpoint, any of these or anything else, is 6.7 units. The circumference. Circumference can be found by 2 pi r, or diameter times pi. Because we have the diameter, it would be a waste to multiply this by 2. We have it. It's 13.4. So circumference is 13.4 pi. Because this worksheet specifically asks to use the pi button on your calculator and round to 2 decimal places, I gave you that answer as well in the answer sheet, and you get that that is 42.10 units when you correctly round. Okay, so there's your radius and circumference. Moving on to the next page. Okay, you have a radius of PA right here. It bisects the chord BC. A bisector is something that intersects a segment in such a way that it divides it into 2 congruent parts. So these 2 parts right here are congruent to one another. This is also probably something I should have put on the circle stuff sheet because it was in our notes. When you have a chord or a line that goes through the center of the circle, and it bisects a chord, it is also a perpendicular bisector of that chord. So that's something that, again, might want to write down on your circle stuff sheet. If this bisects it, it's also a perpendicular bisector. We proved that by talking about radii and da-da-da, side, side, side. We did all that stuff. All right? So it must be perpendicular. These are two things that you have to draw out for yourself. They won't tell you that. Okay? So you see that drawing on there. You said, well, how did you get that? Well, I got it through stuff that you're going to have to know. Okay? BC is 14, so this entire thing is 14. So you know, if all of this is 14, then both of these are 7. Because it's a bisector, divides them in half. Or it divides them by 2. And AN is 3. So this short segment right here is 3. We need to find the length of PN right here. Okay? Now, this radius bisected this. This chord did not bisect this. So you can't say if this is 3, then this is 3. We have to find out what this thing is by finding out what the length of the entire radius is. So what would help here? First of all, it would help if I erase some stuff, because this gets a little confusing looking at it all. I'm going to go ahead and just look at one right triangle. If I found, let's see here. See this radius here, AP? It's important to know that a radius exists everywhere in your circle. If this is a radius, so is this right here, AB. So I'm going to go ahead and erase AP. I'm going to stick in AB right here. Notice here I have a right triangle where I have lengths 3 and 7, legs 3 and 7, and a hypotenuse that is unknown. If I solve for this hypotenuse right here, let's call it C. Whoa. Hypotenuse, let's call it C. Then I would solve for the whole segment right here, AP. If I subtract 3 from AP, AP minus AN, I will get PN. So I have AN, which is 3. I need to find out what AP equals. AP equals AB because they're both radii. So if I find AB, then I find AP. If I find AP, then I can find PN. Okay, Pythagorean Theorem here. A squared plus B squared equals C squared. 3 squared plus 7 squared equals C squared. 3 squared is 9. 7 squared is 49. So C squared equals 58. C equals the square root of 58. So my length right here, my radius is square root of 58. So this is square root of 58 as well. So I can do square root of 58 minus 3, and I'll get PN. Let's go ahead and round to 2 decimal places. You punch it in your calculator. You do all the stuff. You get PN is about 4.62 units. Okay, so this length right here is 4.62. Okay, your area of a circle is pi r squared. We know that our radius is square root of 58. I want to use this exact number. Okay? Square root of 58. So A is pi times the square root of 58 squared. Square root of 58 squared is 58. So your area is 58 pi. You use your calculator, punch it in, round to 2 decimal places, you get area is 182.21 square units. Okay, so that's the area of the entire circle right there. All of that good stuff right there is 182.21 square units. Okay, number 5. Here's the information that they give you. Circle O, that means O is at the center. It says QP is tangent at point Q. So that means a radius, right here, like OQ, intersecting with the tangent line creates a right angle. Have to recognize that, absolutely. OA equals 6. So they tell you this length right here is 6. They tell you this length right here, AP, is 2. They say, what is the length of PQ? What is the central angle measure of angle AOQ? Something right here, something right here, we're going to have to use trigonometry. Good practice here. Hopefully you all watch this video. Okay, I got OA is 6, AP is 2. I need to find what this is. I know that all of this is 8. That's a good start. So let me go and erase this. I want to say OA or OP equals 8. Okay, it looks like here, you're like, this thing looks like a right triangle. Well, it is. If only I knew what OQ was, I could use Pythagorean Theorem and solve for this. And you're like, okay, well, what is that? Well, we know that OA is 6. OA is not only 6, but OA is also a radius of your circle. So this is something that's so super crucial. You have to recognize when they tell you this stuff. They're trying to trick you. Or, I'm sorry, they're not trying to trick you. They're trying to test what you know. They're trying to say, OA might be 6, but OQ also has to be 6. Because these guys are congruent because they're both radii. So your understanding of what definitions are and such is super crucial to solving all this. And now I need to find QP. Let's call it x. So Pythagorean theorem says a squared plus b squared equals c squared. 6 squared plus x squared, remember that's a leg, equals 8 squared. That's 36 plus x squared equals 64. Subtract 36, you get x squared equals, was that 28? Where's my answer sheet? There it is. X squared is 28, so x equals 2 times the square root of 7 units. That's QP, by the way. QP is 2 root 7. So 2 root 7, multiply in your calculator, do all that stuff. You get about 5.29 around to 2 decimal places. So this right here is 5.29. That's an approximated number, though. So when we solve for this one right here, the measure of angle AOQ, I don't want to use 5.29 in my trig because it's only a rounded number. I'm going to use exact numbers 6 and 8. So I need to find the measure of angle AOQ right here. Let's go and call this one x now. This is another one that I'm not sure of. I don't know what the answer is here. Well, what I do know is that this is a right triangle. And I have a leg that's known. I have a hypotenuse that's known. This leg is adjacent to this angle here. This hypotenuse is there. So that's A and H. That matches with Ka in SOHCAHTOA. So I want to use Ka. I want to use cosine. The cosine of my angle, x, equals 6 over 8. Adjacent over hypotenuse. Okay? To solve for x, you need to find the inverse of the cosine of x. That's taking the inverse cosine. So the inverse cosine of x, do the inverse cosine on both sides. And you'll get that x equals the inverse cosine of 6 over 8. I think I put 3 over 4 in your answer sheet. I just simplified the value. Okay, this is something you have to know how to press on your calculator. You have to know what your calculator looks like, have to know where cosine -1 is, how to enter it to get the angle itself. And you'll get x equal, well, the angle, I'll put it right here, equals about 41.41 degrees. Okay, so there's that angle right there. Okay, I didn't use 5.29. I didn't say sine of x or tangent or anything because I don't want to use an approximated value here. That'll give me a different number because this number really wasn't 5.29. It was 5.285 or whatever it was. I want to make sure I get exact numbers. I have 6 and 8. Let's use those instead. Okay, an 8-inch dinner knife right here. It doesn't look like it. Oh, here it is. An 8-inch dinner knife is sitting on a circular plate so that its ends are on the edge of the plate. So here's an end point, here's an end point. It forms a chord. If the minor arc that is intercepted by the knife measures 120 degrees, find the diameter of the plate, show all work. So this portion right here is 120 degrees. Okay, that's an intercepted arc. Here you have a center point. The center point creates a central angle right here with these two radii. This central angle is also 120 degrees. Central angle and intercepted arc have the same angle measure. Okay. What I'm going to do for you, we need to find out what the, let's see, what do we need to find? Find the diameter. If we need to find the diameter, like this, D, then we need to find the radius. This radius here, R, is something that would be nice to find. In order to find that, normally you have to do something like, oh, let's say Pythagorean theorem. Let's say we need right triangles, etc., etc. So here's what I'm going to do. I'm going to erase some of this. Remember that that part was 120. I'm going to create a perpendicular bisector for this right here. It's going to be, boom, it's going to go straight through like that, perpendicular, and bisects the angle. Oh, I'm sorry, bisects the segments right here and here. So these are congruent. If this whole thing was 8, now a small portion of it is just 4. 4 That one's also 4, but I'm only going to look at one of them. This is perpendicular. Okay? Another thing is because it was a perpendicular bisector, I drew it straight through. So it also bisects this central angle right here. So if this whole thing was 120, half of it is 60. 60 degrees right there. Okay? So that's 60. This is a special triangle where it's 30, 60, 90, but there's not an easy special relationship to get from here to your radius. You'd have to divide by root 3, then multiply by 2. So I'm going to save the time. I'll just do trigonometry here. So I know this angle. You also know this is 30, so it's up to you to choose which one you want. I'm going to take the sine of 60 because I have opposite over hypotenuse. So the sine of 60 degrees equals 4 over r. We need to find this radius here. Multiply both sides by r. The r's cancel here. Divide both sides by sine of 60. This is one of those math tricks where it's like I shouldn't have to put all this, and these cancel. You're going to get r equals 4 over the sine of 60 degrees. I'm not going to approximate that for you right now because I need to find different values. I need to find out what the diameter is, which is 2 times r. So that's 2 times 4 over the sine of 60. That's a 6, which is 8 over the sine of 60. If you want an approximation of that, it's about 9.24 inches. If you plug that in your calculator. So there you go. There's your diameter right there, 9.24. So again, this problem was a little hard to set up. You have to recognize what you can do with this. Create right triangles, right? Do what you can with this thing. Try and figure it out that way. You can create a relationship there with the right triangle, use trigonometry. A lot of this has trig in it. It's going to be tough to determine, but a lot of it has trig. Quick water break as you look at that problem. 1 second. Okay, moving on to the next page. Okay, problem number 7 here. They say XA and XB are tangent segments of circle O. So before you begin, you automatically know that these two are congruent. Let's see if we need that. But these two are congruent. They're tangent segments from one point. They have to be congruent. If XA is 24, XB is 24. If XA is 24 and XO is 25, so this whole thing right here is 25. Again, good to write down. Then find the radius, OA. So we need to find this. And it says find the length of AB. Arc AB. Oh, I'm sorry, arc. Arc AB would be the minor arc. Hello. So we need to find this minor arc right here. Okay? So here's what I'm going to do for you. Radius intersects with tangent line at 90 degrees. So, even if you knew this was a right triangle, you have to make sure that you know where the right triangle exists. A lot of you might see this thing and you might say, here's the right angle and here's the hypotenuse. No. You can tell us for a few things. One, it's not, even though it's not drawn to scale, you know this doesn't look like a right angle. Two, a leg, if this was, a leg can't be longer than its hypotenuse. So you're going to end up getting a negative answer. That wouldn't work anyway. The right angle is over here. So 25 is your hypotenuse. 24 is a leg. This unknown leg, OA, let's call it X right now. Let's solve for it. No, actually, let's call it R because it's a radius. Let's say R squared plus 24 squared equals 25 squared. You can use Pythagorean Theorem. I think on my answer sheet I stopped right here because I know my own special triangle. Don't take my word for it, though. Do it yourself. Use Pythagorean Theorem. But you'll end up getting R equals 7. You get 625 minus 576. You take the square root of 49. You get 7. Okay. So your radius now is 7. Okay. So we found radius OA right there. Now it says find the length of AB. Okay. This one's a little tricky for a few reasons. One, you have to understand that they say length, not the measure. So we're not trying to find what the measure of this is in degree. Well, okay, so it's tricky for even another reason for that. You need to make sure, I need to keep that. You need to make sure that you know we're talking about this right here and not this right here. We need to know that we're looking at the minor arc, AB. And the second thing is we need to find the length of it, the actual length in units, okay, in centimeters, whatever, not the degrees. Big difference. So as we find that, we know that we need to still find this central angle right here. Okay? In order to find the central angle, here's what we got to do. Let's call this, I think in my answer sheet I called it Y. Let's find this angle measure right here. I called it Y because there's an X right here. Let's call this angle measure Y. If this is Y, this one's also Y because you have congruent triangles right here. These are corresponding parts. So together, this ends up being 2Y. So if I find the central angle, that would be equal to 2Y. So setting up a proportion right now, before I even begin finding that angle, setting up the proportion is the central angle over 360 is equal to the length of the arc we're trying to find over the circumference of the entire circle. The circumference is 2 times pi times your radius, which is 7. Okay? So before we even, so let's see, so that's 14 pi. Let's go ahead and write that right now. So we set up our proportion a little prematurely. We still need to find out what y is, but as we do this, this will help us find the length of arc AB. Okay, solving for y, this y right here in a right triangle, I can use trigonometry. You can choose which one you want, which value you want to use. You can say cosine of y is 7 over 25. I think I used sine of y in my answer keys, so to be consistent, let's say sine of y equals 24 over 25. To solve for y, you need to take the inverse sine, arc sine right here. So sine -1. So y equals arc sine of 24 over 25. You punch that into your calculator the way that you know how to. Make sure you know how to. And y equals about, well, let's see. I didn't put what it equals about because I didn't want to approximate yet. 2 times this number is 2 times the sine of -1, 24, 25. That number becomes about 73.74 degrees. I should have been better than that. I should have left it as is, but in my calculator I did anyway. I didn't use this rounded number. I used exactly what it was. So here on top, you set up this proportion. Your central angle, this entire thing right here, this 2y, that's 73. It's about 74 degrees. So 74 out of 360 will equal this length out of the circumference of your entire circle. Whatever fraction this is out of 360 is the same as whatever this fraction is out of the entire circle. That's what this proportion means. So 73.74 degrees out of 360 equals AB over 14 pi. Multiply both sides by 14 pi. You'll get AB equals about 9.01 units, or about 9 units. If you got 9 as an answer, I suppose that's okay as well. So 9.01. So that's the length of this guy right here. Okay? Okay, find the value of x in each figure below. Here we have a tangent line and a secant line right here. And we can use a relationship here that says this angle measure is equal to half the measure of this arc minus this arc. So 40 degrees equals 1/2 of x minus 60. Let's solve for x. You can choose to distribute the 1/2. I'd rather multiply both sides by 2. Cancels out the 1/2 with the 2, and you get 80 equals x minus 60. Add 60 to both sides, you get x equals 140 degrees. So this arc right here is 140. Okay, 2 secant lines. These are now lengths. Remember this setup as you do this proportion here. I'm going to do the outside of this segment times the whole thing equals the outside of this segment times the whole thing. So I'll get 6, I'm going to write it a little thicker, 6 times 6 plus x equals 8 times 8 plus 12. Okay, that's my setup to solve for this. Distribute. I'll get 36 plus 6x equals 8 plus 12 is 20. 8 times 20 is 160. So that equals 160. Subtract 36 from both sides. I get 6x equals 124. And x equals, what will that be? 120, 20 and 2/3. 20 and 4/6 and 2/3. That's about 20.67 when you round it. So there's your x length right there. .67, and this was 140 degrees. Okay. Find the value of x and y in the circle at right. Now it's funny that they didn't ask you to solve for w and z. However, you might want to choose to solve for w and z as you do this problem, and I'll do the two different ways you can solve this problem. The first way is the way that you see on the answer sheet here. Well, you have to do this first. You have to solve for x first. It's the only information you can really get out of this. I don't know what x is, but I know if I added up all these arcs together, I get 360 degrees. So start setting that up. I got 4x plus 2x plus 3x plus 6x equals 360. Combine like terms, you get 6x, 9x, 15x equals 360. Divide both sides by 15, you get x equals 24 degrees. So there's your value for x. So if x is 24, then I know that this guy here is 48. That's a 4. And this guy here is 24 times 6. That's 144. So these intercepted arcs here are 48 and 144. These will help me solve for y. Okay? Remember, y, this angle right here, is this arc plus this arc over 2. If you look at it on your sheet, it's the one, I think it's on the top right. It says theta equals r plus t over 2. Your theta is the guy on the inside. Your r is this intercepted arc. Your t is this intercepted arc. All divided by 2. So y equals 144 plus 48 all over 2. 144 plus 148 is 192. 182 all over 2 is 96. So y is 96 degrees. Okay? The other way you can solve this problem is by solving for w and z first. And the way to do that is you'd say w is an inscribed angle. And this inscribed angle, well, different color. This inscribed angle has an intercepted arc of 3x. Now 3x is 3 times 24. 3 times 24 is 72. So w equals 1/2 of 72. So w equals 36 degrees. Z, you can do the same thing. Z has an inscribed angle right here, or z is an inscribed angle. Its endpoints create an intercepted arc that is 4x. Now 4x is 24 times 4, which is 96. So z is half the measure of that. Z is 1/2 of 96 degrees, which is 48. So now you have that z is 48, w is 36, and y would be whatever's remaining that adds up to 180. This is a triangle right here with angles 36 and 48 and y. So y plus 36 plus 48 equals 180. Add these up. 36 plus 48 is 84. So y plus 84 is 180. Subtract 84 from both sides, you'll get y equals 96 degrees that way as well. So there are two different ways to do that problem. The second one I didn't show, I just explained. I said, or solve for inscribed angles w and y and solve for it. And again, I'm surprised they didn't say solve for w and y in this problem. They just didn't. Or w and z. But you can choose to solve for them, and they'll still help you solve for y. That's why they give you them. They say, all right, you can choose to do it if you need to. Okay, there's the bottom of that page. Final page. Okay, problem number 10. In the diagram, circle O, assume measure of arc AE is 50. That's this minor arc right here. So as long as you know where you're looking here, and you can say that's 50 with a clean conscience, I gotcha. So that's 50 degrees. Measure of arc AC is 120. So boom, right there is 120. And we have to find all these guys right here. Okay, find the measure of angle 1. Angle 1 is right here. If you noticed, it is an inscribed angle, and its intercepted arc was AE, which is 50 degrees. So angle 1 is 1/2 of 50. It's probably on your sheet. It's 50 over 2. Measure of angle 1 is 25 degrees. Okay? So 1, as I write these, some of them might help you solve other problems. So I'm going to fill them in as I go. So that's 25 degrees. Part B, measure of arc BE. BE is right here. You might start looking at things like, okay, here's BE. I don't have an inscribed angle that matches up with it, so I can't do anything there. But what you do have is they say it's circle O. AB intersects through circle O, so AB is a diameter. If AB is a diameter, then here I have a semicircle from A to E to B, right there. So if this whole thing is 180 degrees, then BE equals 180 minus this portion right here, 50 degrees. So that's 130 degrees right there. So BE is 130 degrees, and that's 50. Okay, measure of angle 2. So this is an example where you see angle 2 is an inscribed angle. Here are its endpoints, B and A. B and A form a diameter. A diameter creates a semicircle right here that measures at 180 degrees. So does the central angle. This is 180. The inscribed angle is half the measure of its diameter, of its central angle and its intercepted arc. So if both of these are 180 degrees, angle 2 is 180 over 2, which equals 90 degrees. You could have done it on the way in the answer key. I think I did. I'm not sure what I did in my answer key. I think I was just messing around. I think I found other angles. I think I found out this was 90 and stuff like that. I totally was working the other way with that problem. This was probably a better way for me to describe it. Okay, part D. Measure of arc CB, right here in blue. CB. Notice this is also part of a semicircle all the way around. This ACB is also 180 degrees. This portion right here is 120. So here you're going to do 180 minus 120, and you're going to get 60 degrees. That's the measure of that arc right there, 60. And finally, measure of angle CAB. C to A to B. This is an inscribed angle right here with its endpoints creating an intercepted arc of 60 degrees. The inscribed angle is half the measure of its intercepted arc. So CAB is 60 over 2, which is 30 degrees. Okay. So got that one out of the way. That one's 30 degrees. All good. 2 more problems. Problem number 11. In circle O, PA and PB are tangents. Let's see, I want to make sure I have some good stuff to write. PA and PB are tangents, so you automatically know a couple things. First of all, these two are congruent. You know circle O means circle, or this O is at the center of your circle, so these are radii. Radii intersect with tangent lines at 90 degrees. This is stuff you can put automatically. By the way, the radii are also congruent to each other. And this is congruent to itself. You have congruent triangles. We already know that. But all this stuff will be important for you to know. Okay, PD, this ray, bisects angle BPA. That means it creates congruent parts right here and here. Okay? We could have also known that by saying it passes through the center. So these are congruent angles. If the measure of angle AOP is 53 degrees, so AOP, if this is 53, that's a 5 degrees. Find the measure of angle APO. Okay? Measure of arc AC, the degree measure, and the measure of angle ADC. Okay, I'm going to do this one at a time. First, let's find the green one, APO. Okay, I'm going to make it a darker green. This is a right triangle, 90 degrees, 53 degrees, unknown. Let's call it X for now. This unknown is 90 minus 53, which is 37. Remember, in a right triangle, all of them add up to 180. However, if you have a right angle, you don't need to factor that one in. Just say this one plus this one equals 90 degrees. So X is 90 minus 53, which is 37. X is 37 degrees, as so. Or measure of angle, I should have put measure of angle APO. Okay? Measure of arc AC, this guy right here. We're trying to find the degree measure, not the length. Okay, this is at the center. You have this as a central angle, 53. Here's its intercepted arc. So measure of arc AC is also the same as the measure of its central angle, measure of angle AOC, which is 53 degrees, right there. Okay, and finally, let's do a different color. Measure of arc ADC is right here. ADC. A and C is this intercepted arc, the same one. Remember, this is 53 degrees. ADC is an inscribed angle. So the inscribed angle will be half the measure of its intercepted arc. Half of 53, which is what, 26.2, not 0.2, 0.5 degrees. Right there. So it's actually a pretty simple problem. I don't know why they give you all this stuff. Well, this is good stuff to set up. You might need it. You never know. So it's always good to have. It would have been nicer if they said, oh, this is 53 degrees, and then you start working through this and all this stuff. All that good jazz. But there you go. And one more problem for you. Number 12. Given the information in the diagram of circle P below, find the measure of angle A, measure of arc ADC, measure of angle P, the length of arc BC. They tell you that right there. Okay. And then the area of circle P. Okay, let's go and get this ball rolling. Measure of angle A. We need to find this angle right here. We have an inscribed angle whose intercepted arc is 42 degrees. So this is, I think that's a D. So this is DAC right there. If this is 42, angle A is half of 42, which is 21 degrees. So A is 21. Write that in if necessary. Measure of arc ADC. Looks like a major arc or semicircle. Or no, I think that they're just telling you, let's go this. Oh, you know what? That's a B. Because this is D. Never mind, this is a major arc. Major arc ADC in big blue right there. Gives you. Check this out. This is 80 degrees. This is 42 degrees. The rest, the unknown, adds up to 360. This plus this equals 360. So 80 plus 42 plus measure of arc ADC equals 360. 80 plus 42 is 122. So 122 plus measure of arc ADC equals 360. Subtract 122, measure of arc ADC equals 138, 238. 238 degrees. Yeah. So that's 238 degrees. Okay, measure of angle P. This drawing doesn't really show up very well showing what P is. I think this is P. Okay, measure of angle P. It says this is circle P. So circle P means that this is the central angle right here. Okay, central angle goes out here. Intercepted arc is 42 degrees. So P, very simply, is 42. Okay, I'm going to skip this one for now. I'll go back to it after because it's the harder or the more explanation one. Area of circle P. Okay, we have a radius of 5 centimeters here. They give you this length is 5. That's one of your radii. So that's all you need. Your area of a circle is pi r squared. So area is pi times 5 squared, which is 25 pi. If you round that value, because that's what we've been doing, multiply by pi in your calculator, you'll get 78.54. They've given us units here. This is centimeters, so this is square centimeters. Okay, finally, length of arc BC. I'll give myself a little more room. Remember, length, this is not measure. We already have this as 42. They're not asking us to say that this is 42 degrees. They want the length. The length of this is based on the circumference of the entire thing. If I find the circumference of the entire thing, I want to find out what fraction this is of this entire thing, and I'll know what it is. Fraction is used by setting up a proportion. This central angle out of 360 degrees will be equivalent to this length out of the entire circumference. So that central angle is 42. So setting this up, I'll get 42 over 360 equals length BC, the unknown, out of the length of the entire circle. The length, the circumference, is 2 pi r, which is 2 times pi times 5. 2 times 5 is 10, so your circumference is 10 pi. So we're going to do BC out of over 10 pi. Okay. I think on my sheet I did a lot of reduction things. Ignore them if you need to. Let's go and cross multiply, and let's do it that way. Or not cross multiply. Do multiply by 10 pi. So we got 420 pi over 360 equals BC, and then you get to do the rest in your calculator as you do it, because it didn't really look like I reduced mine very well as I did it myself. So BC equals, I think it's about, let's see, we got 3.67 centimeters. Okay? BC, 3.67 centimeters. Okay? So that is your solution guide in video form. And I want to do one more thing. I want to go back to circle stuff for you one more time because I feel kind of guilty about something here. I didn't tell you. Here, I'm going back to my marked one. Let's go and save that as is. I skipped out on talking to you about a couple of these formulas in the previous video. As soon as this loads up, don't crash on me. There we go. I didn't mention what... Hello. What these guys all meant right here. Even though I kind of did these, you know what, I didn't do these problems here. So let's go and talk about them. Okay, first of all, A plus B equals 360. This arc plus this arc equals 360 degrees. We know that. Here's another thing I want to talk about. If we have a center point right here, and we draw a radius and a radius, we do know that these intersect at 90 degrees. Okay? If you look at this as a quadrilateral all throughout here, we have this angle is 90, this angle is 90, this angle is x. Now this angle right here is the same, because this is the center, this is a central angle, here's this intercepted arc A, so this angle is also A. So we know that x plus A plus 90 is 360 degrees. But just like that right triangle example I talked about earlier, we can ignore these. If these are always going to be 90 degrees in these examples, because there are two tangent lines here, then let's add these together. You get 180. Subtract 180 from 360, and you get x plus A equals 180 degrees. If x plus A equals 180 degrees, then A, subtract x from both sides, equals 180 minus x. So that's where that first one comes from. So the smaller arc is 180 minus this angle. The other one, B, the bigger arc right here, is, let's go and do substitution here. We got A plus B equals 360 degrees. If we know that A is also 180 minus x, let's substitute this in for A down here. We'll get 180 minus x plus B equals 360, and solve for B. Subtract 180, you'll get negative x plus B equals 180. Add x to both sides, you'll get B equals 180 plus x. Okay, so that was right there. I just felt a little guilty. I know I didn't go over them. I didn't cover them. I wanted to make sure that you got it in some form. I'll make an annotation in my other video and make sure you got that. Okay, but so you got all that stuff there, and I'm signing off. Good luck with everything. Please ask questions as you do. I hope those problems were very, I hope I expanded on them very well for you. And again, if you do have any questions, please let me know.